for second baseband signal, which is 2 cosine 1000 t plus cosine 2000 t, the frequency spectrum is given by 2 pi, right? 2 pi delta, again, because the amplitude is 2 here, so instead of pi, it becomes 2 pi. So there's 2 pi delta omega minus 1000 plus delta omega plus 1000. All right, and then for this cos 2000 t, amplitude is 1, so it's just pi in frequency domain. So pi will be delta of W or omega minus 2000 plus omega plus 2000, right? So we're going to have 4 impulses. All right, one at 1 kilo, 1K or 1000 radian per second. The other one at minus 1K that come from this term here. Then the amplitude of these two are 2 pi. All right. And then for the impulses at plus minus 2000, the amplitude is just pi. Right. So this is the spectral for the baseband signal. All right. Your baseband signal only has 2 frequency components. So when you modulate the signal using double sideband suppressed carrier technique, then you just multiply the carrier with the message, right? So again, you need to work out the result of multiplication. So here again, we do cross multiplication. Yeah. So there will be 2 cos 10,000 t times cos 1000 t. All right, plus cos 10,000 t multiply with cos 2000 t. Yeah. So again, this is cos x cos y. Right, this is cos x cos y. And this one, let's say I call it cos A cos B. Yeah. So again, make use of your trigo identity. Even though I give you a table with many terms in there, many expression in there, basically you're not going to use all of them. So you just need to know where to find the one that you need. All right. Again, I'm going to make use of this one here. Okay. So because I have 2 here, all right, and then this one come with the 2 in front, so therefore it's just cos of oops. All right, there will be cos of again x minus y. I'm looking at this one now. All right, cos of x minus y. X is 10,000, y is 1,000. Therefore, I get 9,000 again. All right, plus cos of 11,000 t plus, okay, this one is cos A cos B. So again, because I don't have a 2 in front, so therefore this is again half. All right, half of cos A minus B is 8,000. A plus B will be 12,000. All right. So next thing is to convert it into its Fourier equivalent. Again, I'm going to use the omega. So what I have here is I have cos 9,000. All right, cosine of 9,000 will give me what? Let's go back. Okay, pi. All right, so this will be pi. Again, I have delta omega minus 9,000 plus delta omega plus 9,000. All right, and then plus delta. This is for the second one. All right, so you can proceed with the rest. Okay, proceed with the rest. And you can see that every cosine term is going to give you 2 delta function. All right, so if you were to draw the spectrum, right? If you draw the spectrum, then you're going to have, all right, so for cosine 9000, I'm going to have one impulse at 9K, another one at minus 9K, right? And the amplitude is pi. Yeah, and then for 11,000, I have I'm gonna have one at 11K. Amplitude same, right? 11K. So another one at minus 11K. All right. And then for 8,000, I'm going to have one at 8K. 8K, you see that amplitude is half. All right, because it's half, so that means it will be pi over 2. Half in time domain, convert to omega, it will be pi over 2. So that will be 8K. All right, and minus 8K. Yeah, and then this one, 12K, same thing, is because of the amplitude is half. So that will be pi over 2 as well. Okay, so that is the spectrum for your double sideband suppressed carrier signal for baseband signal number 2. This is omega. All right. So now where is upper sideband? Where is lower sideband? Okay. Same way. Identify where is your carrier frequency. Carrier frequency is here, 10K. All right, here 10K. So where is your upper sideband and lower sideband? These two is lower than 10K, so it's called lower sideband. All right, these two is higher than the carrier frequency, so therefore it's called upper sideband. All right, on the other side, it's just a reflection, so it's a mirror image, so this is lower sideband. Okay, these two are lower sideband, and these two are upper sideband. Okay. Clear?
Clear.
Good. Then I would like you to go through everything yourself again. Yeah, for the third baseband signal. But be careful of the third baseband signal because if you look at it carefully, all right, it's actually cos 1000 multiplied with cos 3000. All right, so the first step is to convert this expression into the sum of two cosine. Right, again, cos x, cos y. Now it's opposite already. So cos x, cos y, then you convert it into, okay, here. You have cos x, cos y, convert it into this form first. All right, into the sum of two cosine terms. Then only you convert into, convert into the Fourier transform. All right, use the Fourier spectrum transformation only after you have convert these two the product of this cosine signal into the sum of two cosine signal. All right, convert cos x cos y into cos x minus y and plus cos x plus y. Yeah, then from there only you do the transformation and then only you sketch. Yeah, so I leave it for you to do it on your own. Yeah, and then next week, if you have any questions, then we go through again. Is that all right?
Okay, miss.
All right. Okay, so I